Okay, hi guys. Today we're doing a new Leetcode problem called maximum subarray. It's the number 53 problem. Given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. A subarray is a contiguous part of an array. So in this problem, our input is array of nums, and our output is max value of the subarray. So what that means is that we need to find a point in an array up to the end that adds up to the max possible value. So in this case, from 4 to 1 results in 6. That would be the maximum value we can receive by adding up to the adding the elements. And if you look at the second second example, you can see that num's length is 1, so we are returning nums at index 0. So that would be our edge case. So let's say edge case is if nums dot length equals to 0, return nums 0. Sorry, it has to be 1, not 0. Okay, so first let's take care of our edge case. I'm going to say if nums dot length equals to 1, then I will return nums at 0. Okay, so the way we can think of solving this problem is having two values we're going to track. So first, we're going to start summing the elements, and we'll check if that sum is greater than the next element. And if the next element is greater, then we'll just start from the next element. If not, then we'll continue adding the elements to our sum. And our next thing we have to track is the highest value. So every time we find the highest value, we'll update the max value to that highest value. So let me try to explain a little bit better. First, let me try to give us a little bit more space so it doesn't look very messy. Okay, so we're going to start our first variable current with -2, and we'll do the same thing with global, or let's name it max value to -2. Okay, so we're going to, let's say, add -2 and 1. That would give us -1. So we want to decide if we want to keep -1 as our current value, or we're just going to start over and declare 1 as our current value. In this case, it's better for us to take 1 since 1 is larger than -1. So our current value would be 1. So now we would compare our max value, which is -2, to 1, our current value. Check which one is better, right? So in this case, the current one is bigger, so we would we'll make our max value same as current value. Then we'll start over again. So now we have to add 1 to -3, which would result in -2. So in this case, we would have to check, is it better for us to take -2 as our current value, or is it better to take -3? Since we're always taking the largest value, it's better for us to take -2. So in this case, max value is bigger than -2, so we will stick with our max value, which is 1. Then we'll do it again. So we would add 4 to -2, which will be 2. So we want to decide, do we want to start our string from 4, or we want to take the 2? So since 4 is larger, we'll take 4, and for our max value, we'll take 4 since it's larger than 1. So let's do the same thing with the next round. So here we have 4 as a current value, and we have to add -1, which will result in 3. So we have to decide, do we want to keep 3, or do we want to start with -1? Since the 3 is larger than -1, we would use current as a 3. But since 4 is larger than 3, our max value will still be 4. So we would do the same thing here. So 3 plus 2, that's 5. So we want to know if we want to keep 5 or we want to move to 2. So since 5 is bigger than 2, we will make our current value 5 and our max value 5 as well, because 5 is greater than 4. Okay, so now we're going to add current value 5 to 1, which would result in 6. So now we want to check if we want to grab the 6, or should we move to 1. But since 6 is bigger, I'll make our current value 6 and a global value 6. So for our next round, we will add 6 to -5, which will give us 1. So we want to check, should we keep the value 1 or should we start with -5? So it makes sense for us to keep the value 1 since it's larger. But for our global, we'll stick with 6 because 6 is bigger than 1. Okay, so now we are adding our current 1 to 4, which will give us 5. And we want to say, do we want to keep 5 or we want to switch our current to 4? In this case, we would pick 5 since it is bigger than 4, but our max, we would stick with 6 since the 6 is bigger than 5. So at the end, our answer is 6. Okay, so let's try to write this code out. So first, I'm going to say let current equals to nums 0 and let max value equals to nums 0. Okay, so what you're gonna do is iterate over the num. So let's say let I equals to 1, I is less than nums dot length I plus plus. So we're starting with the 1 since we already assigned the 0 to current and max value. So So what we're gonna do is we're going to assign current to the value that's max, right? So the way we do that is we can use a shortcut called mat.max. So like we went over earlier, we're actually comparing current plus nums I and nums I. So that should give us the max value for the current. So in here we can say if current is greater than max value, then max value will be equal to current. So what we're saying is that if the max value is smaller than current, then we want to replace the value of max value with the current. So we could return max value at the end. Okay, so I hope that makes sense to you guys. Okay, so let's try to run this code out, but before I do that, let me try to comment this one out and then try to run the code. Okay, so it's passed, so let's submit. Okay, so yep, that's how you solve it. Yeah, so it's a bit, I know it's a bit confusing at first, but you know, like I did, like I compared the value one by one and tried to compare the values. I feel like that would be very helpful if you were to try to solve this problem again, just to always, you know, look at the previous examples and then see like what happens if you go to the next steps. So hopefully this video was helpful. I'll see you guys later.